Hello, it's Keith here, and this is the second in the YQuest tutorials. Now this is where we look at the little Z80 based game that's going to be multi-platform, porting it to more and more systems as I can. And so I'm going through the code in the hope that you can learn something about Z80 programming. You can have a look and you can download the source code. It's free, it's open source, and you're welcome to modify it and tweak it and make your own game from it if you want. So hopefully this will help you out and you can have some fun with my little game. Anyway, let's just have a quick go at the game and remind ourselves of what it actually does. So you control the little Y in the center of the screen. We press buttons on our keyboard and this changes the acceleration, and we have to collect all the crystals while dodging enemies and mines, and we can shoot those enemies. Can try and get if I can aim properly, which doesn't seem I can. The keyboard's not the greatest of controls for this, but anyway, as I say, basically I got one. Basically, it's just a little fun practice game that kind of proves that from relatively simple programming we can make something that's at least reasonably enjoyable and looks like a legitimate game. And the code that we're going to be looking at today is an extended version of the simple joystick example that we looked at in these Z80 tutorials, and you can see all of the initial development of this game in my live streams on Chibiakima's Live if you would like to do so. Anyway, we're going to go over the first section of the code, the multi-platform code that is common to all the systems today. Let's go over and let's have a look at it. Okay, so I'm in the wrong window, not a good start there. That's because I was compiling the Sam Coupe version there, so for that demonstration. So okay, so this is the first part of the code we're going to be looking at today, and this is the random number generator. Now the random number generator is a little bit more complex than it possibly needs to be. This was designed for my Chibi Aliens game, which is something I've been working on. It's a bit delayed, but it's been something I've been playing with, and that uses pseudo-random number generation to create sort of an artificial universe, and it's supposed to be replicatable random number generation. So it takes a 16-bit parameter and it gives a predictable 16-bit random number as a result. Now, in the case of YQuest, I only needed an 8-bit number, but I wanted to make things easy and use that random number generator I'd already tested and knew would give good random results. So we're going to use that here, and we're going to use this function called doRandomWord, and then we're going to convert that to a random byte later on. So we'll have a look at that in just a moment, but for starters, let's look at this. Now, what this does is it will return a random number, 16-bit random number in HL from a random seed in BC. And if BC is the same every time, the result it will give is the same every time. And this is so that we can generate a random universe in a predictable way so that it's the same every time we visit it. Now, we're going to run two random number generators that generate numbers in different ways, and this is so that there's no predictability in the random pair if we only increment the BC random seed by 1. So the first random byte is basically being generated by a bunch of rotations and XORs of the 2 bytes of the random seed here, with an extra XOR just for added benefit here. And this is a fairly simple random number generator which will create sort of okay results. I think this is pretty similar to the ZX Spectrum built-in one, but it wasn't really good enough for what I needed for Chibi Aliens. It was sort of okay as a part, but for the complete random number generator it wasn't good enough. So that will generate the H byte of the pair. The L byte is generated in a far more complex way here. What we're doing here is we're again using B and C, but this time we're actually looking them up in a pair of lookup tables. Now you can see we're using one lookup table here, one lookup table here. We're masking out the bottom nibble because these are 16-byte lookup tables, and we're actually using the first random number generator as a seed for one of these lookups. And if we look here, you will see, maybe if you saw last week sometime, these are the random number lookup tables here. So this is to allow the random numbers to be as good as possible, because I couldn't, maybe someone with better maths than me could do it, but I couldn't get good enough random numbers for my requirements without sort of more advanced random number generation. The lookup tables helped me out there. So that's the 16-bit random number generator that is the best that I've come up with so far. However, for this game, for YQuest, we only needed single byte random numbers, and we didn't need them to be replicatable. We just wanted a completely random number each time. So the random seed is automatically being incremented here every time we run this function. And we're getting 2 random bytes, and then we're XORing the H byte with the L byte and storing it in the accumulator. So the effect of this is every time we run this command, we'll get a random byte back, different every time. And H, L, B, C, and D, E are unchanged by this. Only the accumulator is different, and the accumulator contains that new random byte here. So that's a good way of quickly getting a random number. If we want to randomize the seed, we can just run this for no apparent reason. So if we're waiting for a fire button to be pressed, if we just repeatedly run this command without using the resulting bytes, it will automatically change the seed for us. Now, in our game, there will be times where we need lots of random numbers, but we won't want them to be 0 to 255. We might want them to be 0 to 40 for a 40 tile wide screen, 0 to 24 for a 24 tile wide screen. Or we may want something else, like if we wanted something in the middle of the screen, we may want it to be from 16 to 32 or something like that. So we want to be able to specify ranges of acceptable random numbers for our generation. And that's what we've got here. So we run this command, which uses the do random again. And we specify a range with B and C here as the minimum and maximum acceptable values. And if we generated a random number that is outside of that range, we just ask for another random number. And this works okay because my random number generator will, on a long enough timescale, result in every possible random number from 0 to 255. If your random number generator wasn't properly tested, shall we say, it might miss like 128 or something. There might be a number that it never actually returned, and that would be a big problem. And that's why I used this probably overcomplicated random number generator, because I knew that that wouldn't occur. So that was just making things a little bit easier for me. Now, this ranged random function we're using then to generate random X and Y positions. There will be times where we need to generate the whole location of an object like this. For example, if we collected a crystal and a new crystal needs to appear, we need to generate a random location somewhere on the screen for it. But when we kill an enemy, the enemy always appears at the edges of the screens out of the way of the middle, so that the player's not likely to immediately collide into them. So we've got a random X position function here, a random Y position function here, and a random both position function here. And you can see the width and height of the screen are being defined by these symbols because that's platform specific. 0, 0 is always the top left of the game screen, but how wide and tall the screen is depends. On the Game Gear it's 20 wide, on the MSX it's 32 wide, and on the Amstrad CPC it's 40 wide. So it just depends, and that's why we're using a symbol there, because that will be defined in our platform specific code. Now you can see these are writing to IX plus XPOS here. Now we looked before at the definitions of our objects, and XPOS here is byte offset 2. Now what this means is that when we run this function, IX should point to the object that we want to reposition on the screen, because this will then change the X position and potentially the Y position of that object, so it's got a new valid position on the screen. Now those are for just randomized object positions, but when we have killed an enemy and we want it to appear on the sides of the screen only, we've got a special function to do that for us. First, we use the random number generator to pick one of the 4 sides. Then we put the object's position on the extremity of that side, and then we select a position within the other axis for the random position of that enemy there. And so that's what we're doing here, a combination of a fixed position based on either a fixed value or the screen size, and a random position either of the X position or the Y position, depending on which side of the screen we chose. Okay, so that's what we're doing to select the position of the enemy when the enemy's been killed. However, when the level initializes or when you collect a crystal, we need to select a new position for that object. However, we need to make sure that a crystal doesn't overlap a mine, for example, because the player will be killed by the mine, but the player can't win the level without collecting the crystal. So if the two are literally over the top of each other, it's impossible to win. So that's not going to be so good, not going to be very fair. So we get around that with this safe randomized object position function. And this will define a new position for IX up to the object count C. And the reason for that is that if we've just started defining the level, we may have only placed 5 objects. So we want to check that the 6th object doesn't collide with the first 5. We don't want to check the full 40 object array. So that's why we're doing that. So IX is the object we have just placed. We want to give it a new random position. IY is used for the objects we're comparing to. So we're loading the first object position here, and we're moving through the array. That's what this does, moves to the next object. We're loading the X and Y position of the object we've just placed, the X and Y position of the object we're testing, And then we're using this range test W, which will do a wide range test and check if the two objects are too close to each other to be acceptable. This will return the carry flag if the object position is invalid. If the object position is invalid, then we are regenerating a random position for the object and trying again. The long and the short of this is, once we've completed our scan of all C objects here, we've decided that the new object position is okay, it's not overlapping anything else, and we can carry on with doing whatever we were doing, either initializing the level or placing the new crystal position. Here's that range test function here. We've got range test wide here, and we've got range test, and we are using HL as the X and Y area around the object that is considered the hitbox for that object. So we are checking if object with X and Y position DE has hit object with X and Y position BC in the range HL here. And so we're just taking the B position, moving to the left, checking the range, moving to the right, checking the range, and doing the same for the top and the bottom of the object. Now, depending on if we find at any point that the object is out of range, we jump over to here, we do an OR of A to clear the carry flag, and then we just return. But if we get down to here, then the object wasn't massively above, massively below, massively to the left, or massively to the right of the test object, and that means it's within that target range. So we set the carry flag and we return here. So this is just an easy way, relatively speaking, of checking if two objects are too close to each other, either because they overlap or because they're too close within that valid range. And this is used for initializing the level, but also for detecting if the enemy has killed the player, if the player's collected a crystal, or if the player bullet has shot an enemy and things like that. So this is used an awful lot. It's quite a nice, simple little routine. Now, this program code uses tiles or software sprites depending on the system. Now, unlike some of my other tutorials which have used a 1-bit per pixel font, this one actually uses a native format font. So on a 16 color system, that's 4 bits per pixel. On the Amstrad CPC, it's 2 bits per pixel. And we're actually using the sprite routines to draw the font onto the screen. So this print char B routine here is actually going to be within the platform specific code, and it's basically going to be the draw sprite routine, very much like the smiley we saw in the Super Simple series. Once we've drawn a sprite, character rather, we then move the X position along so that if we're doing our hello message, each character comes after the last one. We've got a locate command just to set the X and Y position. You'll notice we're only loading the Y position, but we're loading 2 bytes. This is because the X position comes immediately after the Y position here, so we're loading both in one go there, so saving a bit of effort there. And the print string routine is the exact same one we've seen before. Character 255 terminated routine, it just uses this print char routine here. The only difference is this print char routine is now designed to work with a native format bitmap sprite rather than the 1-bit per pixel one, or with an OS call in some cases we've used before. So there we go. So that's all we're going to cover for today's lesson. We're not done here. You know, you may have seen there's a lesson 3 coming along. There's going to be a lesson 4 and a lesson 5 as well. Hope you found this interesting. You know, go ahead and download the source code, maybe have a play with it. You know, maybe you'll enjoy the game, maybe you won't. You can try and make it better if you're feeling adventurous. I'm sure there's loads of things I could have done a better job of, so that could be your homework for you. But anyway, I hope you have some fun with it. I hope maybe you'll learn something from it, and you know, maybe you'll just have some fun playing the game. Whatever you do though, I hope you enjoy assembly and programming in general. Thanks for watching today, and goodbye.